Our solar system is a place of incredible diversity. It is filled with worlds of rock, worlds of gas, and worlds of ice. Each planet tells a unique story of cosmic evolution. Among these celestial bodies, one stands out with a particular elegance. It is a planet adorned with a spectacular system of rings. This planet, of course, is Saturn. It drifts through the cold, dark expanse of space, a beacon of wonder. Saturn is not just another point of light in our night sky. It is a giant, a ruler in its own domain, captivating astronomers and dreamers alike for centuries with its majestic presence and the mysteries it holds. Saturn is the sixth planet from our Sun. This makes it a resident of the outer solar system. It is a gas giant, like its larger sibling Jupiter. This means Saturn doesn't have a solid surface you could stand on. Instead, it is primarily composed of hydrogen and helium, the two lightest and most abundant elements in the universe. Imagine a colossal ball of gas spinning rapidly deep in space. Its sheer size is staggering. You could fit over 760 Earths inside Saturn. Yet despite its immense volume, Saturn is surprisingly light for its size. In fact, it is the least dense planet in our solar system, so light that it would float in a giant cosmic bathtub if such a thing existed. What truly sets Saturn apart, making it instantly recognizable, is its breathtaking ring system. No other planet boasts such an extensive and visually stunning array of rings. While other gas giants like Jupiter, Uranus, and Neptune also have rings, they are faint and wispy by comparison. Saturn's rings are bright, broad, and beautiful. They encircle the planet like a halo, a shimmering disk of countless particles. These rings are not solid structures. They are made of billions, perhaps trillions of individual pieces of ice, rock, and dust, all orbiting Saturn in a cosmic ballet. Their origin and intricate structure continue to fascinate scientists, offering clues about the formation and evolution of planetary systems. This giant world is more than just its rings, however magnificent they may be. Saturn is a complex system in its own right. It possesses a large family of moons, at least 146 at last count, each with its own unique characteristics and secrets. Some are small, irregular chunks of ice and rock. Others are large enough to be considered worlds in their own right, with atmospheres, geological activity, and even the potential for liquid water. Exploring Saturn and its moons is like exploring a miniature solar system full of diverse environments and phenomena. It reminds us that the universe is vast and filled with an endless capacity to surprise and inspire our curiosity. When you think of Saturn, the first image that likely springs to mind is its magnificent rings. These are not mere decorations, they are a colossal dynamic structure, a testament to the forces of gravity and motion in our solar system. The rings stretch out for hundreds of thousands of kilometers from the planet's equator. To put that into perspective, the main ring system would almost span the distance between Earth and our moon if centered here. Yet for all their vastness, the rings are incredibly thin. In most places, they are only a few tens of meters thick, perhaps as thin as a few stories of a building. This incredible thinness makes them seem almost ethereal, like a cosmic illusion. The rings of Saturn are a spectacle of light and shadow, constantly changing as they orbit the planet. They are not solid bands, but are composed of countless individual particles. These particles range in size from tiny dust specks, smaller than a grain of sand, to enormous chunks as large as a house or even a mountain. Imagine throwing 1 trillion icy snowballs mixed with some rocky debris into orbit around a giant planet, and you get an idea of what these rings are like. Each particle follows its own orbit, jostling and colliding with its neighbors, creating a complex and ever-evolving dance. This cosmic dance is governed by Saturn's gravity and the gravitational influence of its many moons. These rings are not uniform. They're divided into several main sections known as the A, B, and C rings, which are the brightest and most easily seen from Earth. Beyond these, there are fainter rings like the D, E, F, and G rings. These sections are separated by gaps, the most famous of which is the Cassini division, a 4,800-kilometer wide gap between the A and B rings. These gaps are not entirely empty, but are regions with far fewer particles. They are often cleared out by the gravitational pull of Saturn's moons, or by complex orbital resonances. The intricate structure of grooves and waves within the rings speaks to a rich history of interactions and ongoing processes. The sheer scale and delicate beauty of Saturn's rings have captivated human imagination for centuries. Ever since Galileo Galilei first observed them in 1610, though his telescope wasn't powerful enough to resolve them clearly, they have been a source of wonder. He initially thought they might be handles or large companion moons. It was Christian Huygens, decades later, who correctly proposed they were a disk surrounding the planet. Today, thanks to missions like Cassini-Huygens, we have seen them in breathtaking detail, revealing a complexity and dynamism that continues to fuel scientific inquiry and inspire awe at the universe's artistry. The rings are a natural laboratory for understanding how planetary systems form and evolve. So, what exactly are these glorious rings made of? The answer is surprisingly simple, yet profoundly beautiful, mostly water ice. Yes, the same stuff that makes up snowflakes and glaciers here on Earth forms the bulk of Saturn's magnificent rings. Scientists estimate that the rings are about 90 to 95% water ice. This ice is not pristine and pure, however. It is mixed with a smaller amount of rocky material, bits of silicate rock, and carbonaceous dust. This combination of materials is what gives the rings their characteristic brightness and reflective quality, allowing them to shine so brilliantly in sunlight, even from billions of kilometers away. The individual particles within the rings are incredibly diverse in size. Some are as small as microscopic dust grains, while others can be as large as a school bus or even a small mountain. Imagine a vast flat river of icebergs, ice chunks and icy pebbles, all circling Saturn at high speed. These particles are constantly colliding, sometimes gently nudging each other, other times shattering into smaller pieces. This constant interaction is part of what shapes the ring structure and keeps them spread out in their thin, disc-like formation. The purity of the ice suggests that rings might be younger than the planet itself, or perhaps they are continuously replenished by some unknown process. The origin of Saturn's rings is still a topic of active scientific debate. One leading theory suggests they are the remnants of a moon, or perhaps several moons that strayed too close to Saturn. Inside a certain distance known as the Roche limit, the planet's tidal forces, the differential pull of gravity across an object, would have been strong enough to rip such a body apart. The resulting debris would then have spread out to form the rings we see today. Another possibility is that the rings are leftover material from the very formation of Saturn and its moons, primordial debris that never quite coalesced into a larger body due to the chaotic gravitational environment close to the giant planet. The ongoing study of the rings provides vital clues not just about Saturn, but about the processes that shape planetary systems throughout the cosmos. The way particles interact, the role of shepherd moons in sculpting the edges of rings and creating gaps, and the subtle color variations within the rings all tell a story. For instance, the reddish hues in some parts of the rings might indicate the presence of organic compounds, complex molecules containing carbon. Understanding the composition and dynamics of Saturn's rings helps us piece together the puzzle of how planets and their surrounding disks of material form and evolve over billions of years. A cosmic detective story written in ice and dust. Saturn is not alone on its journey through space. It is the gravitational anchor for a vast and fascinating collection of moons. As of our current understanding in 2025, Saturn boasts at least 146 confirmed moons, a number that has steadily grown as our observational capabilities have improved. This makes Saturn one of the most moon-rich planets in our solar system, a true celestial monarch attended by a diverse court of orbiting worlds. These moons range dramatically in size, shape and composition, from tiny, irregularly shaped moonlets just a few kilometers across to giants like Titan, which is larger than the planet Mercury and possesses its own substantial atmosphere. This incredible assortment of moons creates a miniature solar system around Saturn. Each moon has its own story, its own unique geological features, and its own set of mysteries. Some moons are heavily cratered, bearing the scars of billions of years of impacts from space debris. These ancient surfaces tell tales of the early, violent history of the solar system. Other moons show evidence of more recent geological activity, such as smooth plains, deep canyons, or even icy plumes erupting into space. The gravitational interactions between these moons and Saturn, as well as with each other and the rings, create a complex and dynamic environment full of orbital resonances and tidal forces that shape their evolution. Among this lunar family, several stand out for their particular intrigue. Titan, the largest, is a world shrouded in a thick, nitrogen-rich atmosphere with rivers, lakes, and seas of liquid methane and ethane on its surface. Enceladus, a much smaller icy moon, surprised scientists by spewing geysers of water ice and organic molecules from its south polar region, hinting at a subsurface ocean. Mimas, with its enormous impact crater Herschel, bears a striking resemblance to the Death Star from science fiction. Iapetus is a two-toned moon, with one hemisphere as dark as asphalt and the other as bright as snow, a puzzle that has baffled astronomers for centuries. Studying these moons offers us a window into the diverse possibilities for worlds in our solar system and beyond. They are natural laboratories for understanding planetary formation, geological processes, and even the potential for habitability. The conditions on some of Saturn's moons, particularly those with subsurface oceans like Enceladus and possibly Titan, raise tantalizing questions about whether life, or at least the conditions conducive to it, could exist beyond Earth. Each new discovery from Saturn's lunar system expands our understanding of what a moon can be, pushing the boundaries of planetary science and fueling our quest to explore these distant, captivating worlds. Section 5. Titan, a moon, shrouded in mystery and haze. Among Saturn's extensive family of moons, Titan reigns supreme not just in size, but in sheer scientific fascination. This colossal moon is a world unlike any other we know. It is larger than our own moon and even bigger than the planet Mercury. What truly sets Titan apart, however, is its atmosphere. Titan is the only moon in our solar system known to possess a dense atmosphere, one that is even thicker and more substantial than Earth's. This atmosphere is primarily composed of nitrogen, like ours, but it also contains significant amounts of methane and other hydrocarbons, creating a hazy orange shroud that completely obscures its surface from visible light telescopes. This thick, hazy atmosphere creates a world that is both alien and strangely familiar. The atmospheric pressure at Titan's surface is about 50% greater than Earth's. If you could stand on Titan and survive the frigid temperatures of around minus 179 degrees Celsius or minus 290 degrees Fahrenheit, you would feel a pressure similar to being about 15 meters underwater on Earth. The sky would appear a perpetual orange-brown due to the hydrocarbon smog. This smog is created by sunlight and Saturn's magnetosphere interacting with the methane in Titan's upper atmosphere, breaking it down and reforming it into more complex organic molecules that then rain down onto the surface. Beneath this thick haze, the Cassini-Huygens mission revealed a landscape of incredible complexity. Titan has a methane cycle that is analogous to Earth's water cycle. Methane exists as a liquid, solid, and gas on Titan. There are vast plains, dune fields made of hydrocarbon sands, and networks of rivers, lakes, and even seas composed of liquid methane and ethane. The Huygens probe, which landed on Titan in 2005, sent back remarkable images of a shoreline and drainage channels, providing direct evidence of these liquid features. Imagine a world where it rains gasoline, and rivers of natural gas carve valleys through icy mountains. This is the reality of Titan. The presence of abundant organic molecules and liquid on its surface makes Titan a prime target in the search for environments that could potentially support life, or at least provide clues about the chemical pathways that lead to life. While the extreme cold and the nature of its liquids, hydrocarbons instead of water, make Earth-like life unlikely on the surface, scientists speculate about the possibility of life in a subsurface ocean of liquid water, believed to exist deep beneath Titan's icy crust. Titan's unique chemistry, driven by methane and sunlight, offers a natural laboratory for studying prebiotic chemistry, the chemical reactions that occurred on early Earth before life arose, making it a compelling destination for future exploration. Section 6. Enceladus, an icy moon with hidden surprises. While Titan captures attention with its size and atmosphere, another of Saturn's moons, the much smaller Enceladus, has emerged as one of the most exciting and promising locations in our solar system for the search for extraterrestrial life. Enceladus is a relatively small icy moon, only about 500 kilometers or 310 miles in diameter, roughly the width of Arizona. Its surface is incredibly bright, reflecting almost 100% of the sunlight that strikes it, making it one of the most reflective objects in the solar system. This high reflectivity is due to a continuous blanketing of fresh, clean ice particles, a clue to the moon's dynamic nature. The biggest surprise from Enceladus came from the Cassini spacecraft, which discovered enormous plumes of water ice, water vapor, and organic molecules erupting from tiger stripes, long parallel fissures near the moon's south pole. These geysers shoot hundreds of kilometers out into space, feeding Saturn's E-ring with icy particles. This discovery was monumental. It indicated that Enceladus is geologically active and, more importantly, that it likely possesses a subsurface ocean of liquid water. The tidal forces exerted by Saturn are thought to generate heat within Enceladus, keeping this ocean from freezing solid despite its distance from the Sun. The composition of these plumes has been analyzed by Cassini's instruments, and the findings are tantalizing. Along with water ice, the plumes contain simple organic compounds like methane, as well as carbon dioxide, carbon monoxide, salts, and silica nanoparticles. The presence of silica is particularly significant as it suggests that the subsurface ocean is in contact with a rocky core, and that hydrothermal vents, similar to those found on Earth's ocean floor, might be active. On Earth, such hydrothermal vents teem with life, providing energy and chemicals that support entire ecosystems independent of sunlight. This raises the incredible possibility that similar conditions and perhaps even life could exist within Enceladus. The implications of a habitable environment on Enceladus are profound. It means that the ingredients for life, liquid water, organic molecules, and an energy source can be found in unexpected places, far from the sun's warmth. Enceladus has shifted our understanding of where to look for life beyond Earth, highlighting the potential of icy moons throughout the outer solar system and beyond. Future missions are being planned to return to Enceladus, perhaps even to fly through its plumes again with more advanced instruments, or even to land on its surface to further investigate its subsurface ocean and search for biosignatures. This small icy moon has become a beacon of hope in our cosmic quest. Section 7: Saturn's wild atmosphere, storms, winds, and hexagons. Saturn, like its fellow gas giants, possesses a turbulent and dynamic atmosphere, a swirling canvas of clouds, winds, and colossal storms. The visible surface of Saturn is actually the top of its cloud layers, primarily composed of ammonia ice crystals. Deeper down, there are believed to be layers of ammonium hydrosulfide clouds and, further still, water ice clouds. The planet's rapid rotation, completing a day in just over 10.5 Earth hours, combined with heat rising from its interior, drives incredibly fast winds. Near the equator, these winds can reach speeds of up to 1,800 kilometers per hour, or about 1,100 miles per hour, making them some of the fastest in the solar system. These powerful winds stretch the clouds into bands parallel to the equator, similar to Jupiter's famous belts and zones, though Saturn's bands are generally more subtle and less colorful. Periodically, however, massive storm systems erupt in Saturn's atmosphere. These storms, sometimes called Great White Spots, can grow to be thousands of kilometers across, large enough to encircle the entire planet. They are thought to be analogous to thunderstorms on Earth, but on a vastly larger and more energetic scale. These megastorms can rage for months, dredging up material from deeper within the atmosphere and significantly altering the appearance of the cloud tops. They provide insights into the complex meteorology of gas giant planets. One of the most bizarre and captivating features of Saturn's atmosphere is a persistent six-sided jet stream known as the hexagon, located at its north pole. Each side of this hexagon is wider than Earth itself. This remarkable geometric pattern was first observed by the Voyager spacecraft in the 1980s and has been studied in detail by the Cassini mission. It is a stable weather pattern, a wave in the jet stream that rotates with the planet. Scientists have been able to replicate similar hexagonal shapes in laboratory fluid dynamics experiments, suggesting it's a natural consequence of certain types of fluid flow on a rotating sphere. But its precise formation mechanism on Saturn is still an area of active research. Beyond the hexagon and the giant storms, Saturn's atmosphere also exhibits other fascinating phenomena. There are powerful lightning discharges, thousands of times stronger than those on Earth, and auroras at its poles, similar to Earth's northern and southern lights, but much larger, and driven by the interaction of Saturn's powerful magnetic field with the solar wind. The study of Saturn's atmosphere helps us understand not only the weather on this distant giant, but also the fundamental principles of atmospheric physics that apply to planets everywhere, including our own. It's a world of extreme weather, where the scale and power of nature are on full display, reminding us of the dynamic forces shaping planetary environments. Section 8. Echoes of Antiquity, Saturn in Human Culture. Saturn's commanding presence in the night sky has not gone unnoticed by humanity throughout history. Long before telescopes revealed its rings, this slow-moving, golden-hued planet captured the imagination of ancient cultures around the world. To the ancient Romans, Saturn was the god of agriculture, harvest, and time. He was a prominent figure in their mythology, associated with wealth, abundance, and a mythical golden age of peace and prosperity. The Roman festival of Saturnalia, held in December, was a time of feasting, gift-giving, and a temporary subversion of social norms, a precursor to many modern winter holiday traditions. Our own word, Saturday, is derived from Saturn's day. In ancient Greek mythology, Saturn was equated with Cronus, the leader of the Titans and the father of Zeus, or Jupiter in Roman myth. Cronus was a complex figure associated with the passage of time and the cyclical nature of generations. He was said to have ruled during a golden age, but was eventually overthrown by his son Zeus. These myths, rich with symbolism, reflect humanity's attempts to understand the cosmos and their place within it by personifying the celestial bodies they observed. The slow, steady movement of Saturn across the constellations, taking nearly 30 Earth years to complete one orbit around the Sun, likely contributed to its association with time, old age, and the inevitable march of destiny. Even in other ancient cultures, Saturn held significance. In Hindu astrology, Saturn is known as Shani, a deity who judges good and bad deeds and is often associated with discipline, asceticism, and challenges that lead to spiritual growth. In ancient Babylonian astronomy, it was called Kaiwanu, or the Steady One, again referencing its slow movement. These varied interpretations highlight how different societies observed the same celestial object and wove it into their unique cultural and spiritual tapestries. The planet's distinct golden color and its unhurried pace made it a notable fixture in the celestial drama observed by early stargazers, a guiding light and a source of potent symbolism. The legacy of Saturn in human culture extends beyond mythology and ancient observation. Its name graces scientific missions, inspires artists, writers, and musicians, and continues to symbolize both the remote and the magnificent. The discovery of its rings by Galileo and later Huygens revolutionized our understanding of the solar system and our place within it, challenging preconceived notions about the perfection of celestial spheres. Saturn, therefore, represents not just an astronomical object, but a long-standing point of connection between humanity and the cosmos, a celestial body that has fueled our curiosity, our storytelling, and our scientific endeavors for millennia, reminding us of our innate drive to explore and understand the universe. Section 9. The Enduring Allure. Why Saturn Beckons the Curious Mind. Saturn, with its ethereal rings and complex system of moons, continues to exert a powerful pull on our collective imagination and scientific curiosity. It is more than just a beautiful object in the sky. It is a dynamic world, a miniature solar system that offers profound insights into the workings of the universe. The sheer scale of its rings, composed of countless icy particles, challenges our intuition about how such delicate structures can form and persist over cosmic timescales. Studying them helps us understand the fundamental physics of orbital mechanics and the processes that might have shaped the early solar system, including the formation of planets and their satellites from protoplanetary disks. The exploration of Saturn's moons has revolutionized our understanding of where life might find a foothold beyond Earth. Titan, with its thick atmosphere and methane lakes, presents an alien yet strangely familiar landscape, a natural laboratory for studying complex organic chemistry and the potential for non-water-based life. Enceladus, with its erupting plumes and subsurface ocean, has emerged as a prime candidate for harboring a habitable environment, possibly with hydrothermal vents providing energy for life. These discoveries force us to broaden our definition of habitability and inspire new strategies in our search for life elsewhere, reminding us that the universe is full of surprising possibilities. Saturn also serves as a crucial laboratory for understanding planetary atmospheres and magnetospheres. Its powerful winds, colossal storms, and the enigmatic North Polar hexagon provide data that helps refine our models of atmospheric dynamics on gas giants. Its vast magnetosphere, interacting with the solar wind and its icy moons, creates complex auroral displays and radiation environments. By studying these phenomena at Saturn, we gain comparative insights that illuminate the behavior of other planets, including our own Earth, and even exoplanets orbiting distant stars. Each piece of data, each image, adds another brushstroke to our portrait of this magnificent world. Ultimately, Saturn's allure lies in its capacity to inspire wonder and drive our innate human desire to explore and understand. It represents the frontier of our knowledge, a place where beauty and mystery converge. The questions Saturn poses about its origins, the evolution of its rings, the nature of its moons, and the potential for life are fundamental to our understanding of the cosmos and our place within it. As we continue to send robotic emissaries and peer through powerful telescopes, Saturn will undoubtedly reveal more of its secrets, further fueling our curiosity and reminding us that the universe is a vast, awe-inspiring, and endlessly fascinating place, beckoning us ever outward.